When you think about what drives our planet, you might picture volcanoes erupting or continents drifting apart. But the real engine room, the silent powerhouse of Earth, lies much, much deeper. Welcome to the lower mantle. This isn't just a layer of rock. It's a colossal, high-pressure world stretching from about 660 kilometers all the way down to 2,900 kilometers beneath our feet. This is where the rules of chemistry bend, where familiar minerals transform into exotic, super-dense forms, and where the true heartbeat of plate tectonics begins. It's the planet's deep memory, and it's absolutely fascinating. Down in the lower mantle, nothing stays ordinary. The pressures are so immense they crush atoms together, and temperatures can soar over 4,000 degrees Celsius, rivaling the surface of the sun. Under these extreme conditions, common minerals recrystallize into new, super-strong phases. The most abundant mineral on our entire planet is called bridgmanite. You've probably never heard of it because it can only exist under the crushing pressure of the lower mantle. It's incredibly strong and resists deformation, which has a huge impact on how heat moves deep inside the Earth. Then there's ferropericlase, another key player that controls how the lower mantle flows like an ultra-viscous liquid over millions of years. And let's not forget calcium silicate perovskite, which helps lock away certain elements deep within the Earth. Together, these minerals make the lower mantle incredibly stiff, dense, and sluggish. Imagine pressure up to 1.35 million times what you feel at the surface. Down there, rocks don't melt, they flow. This slow, relentless flow is called mantle convection, and it's the piston driving Earth's engine. It's what powers plate tectonics, fuels volcanism, and dictates how our planet cools over geological time. The lower mantle acts like a giant conveyor belt for heat. Hot material rises from the boundary with the core, while cold, dense oceanic plates sink down from the surface. This creates massive, swirling convection currents that are responsible for so much of what we see on the surface. They feed volcanic hotspots like the one that formed the Hawaiian Islands. They assemble supercontinents and then tear them apart. In essence, the lower mantle functions as Earth's planetary thermostat, regulating its internal temperature. But it gets even weirder. Right at the bottom, near the core mantle boundary, scientists have detected mysterious structures. There are ultra-low velocity zones, or ULVs, which are thin patches of what might be partially molten rock. We also see the remnants of ancient oceanic plates, called slabs, that have sunk all the way to the base of the mantle, carrying surface materials deep into the planet. This region is also the birthplace of massive mantle plumes, columns of hot rock that rise for thousands of kilometers to create massive volcanic provinces. So why does all of this matter? Because the lower mantle is the archive, the engine, and the regulator of our entire planet. It controls how fast the Earth loses heat, the strength of mantle plumes, the speed of plate tectonics, and the cycling of critical elements like carbon and water. If the crust is Earth's skin and the upper mantle is its muscle, then the lower mantle is its deep, slow-beating heart. Thanks for joining me on this journey deep inside our world. If you found this fascinating, hit that subscribe button for more explorations into the secrets of our planet.